Okay, this tutorial is to show you how to calculate the escape velocity on any planet given that planet's radius and that planet's mass. We will start with the planet Earth, knowing that the mass of Earth is 5.97 times 10 to the 24th kilograms, and the radius of Earth is 6.38 times 10 to the 6th meters. We can calculate the velocity necessary to escape Earth's gravitational field. And we'll repeat this for the other planets, given their mass and average radius. Open up your TI Nspire calculators. And since we're going to use the universal gravitation constant g, I want to remind you, instead of typing in 6.67 times 10 to the negative 11th, we use the double E, negative 11th, for scientific notation, and we will store that as the letter G. Press Control, var, that'll store that number into any letter. We choose G for gravitation constant. It should be a capital G, but it always registers as lowercase g. But that, anytime you enter the letter G now, it represents that constant value. The escape velocity necessary to escape any planet is always equal to the square root of 2 times g times the planet's mass divided by its radius. So 2 times g times 5.97 times 10 to the 24th kilograms divided by Earth's radius of 6.38 times 10 to the 6th meters. Enter, and it takes approximately a little over 11,000 meters per second to escape Earth's gravitational field. Repeat this process for the other planets given their mass and radius.